So the goal for today is that we're going to be solving area problems involving inscribed figures, and you have a couple pictures of what inscribed figures are. It's just a shape inside another shape. Okay, so I define it up there. An inscribed figure is a polygon within another polygon, usually with some sides or edges touching. So I have a problem up here kind of to think about to start with. Bruce has a square piece of wood that has sides 16 inches long. If he cuts a circle with a radius of 8 inches from the wood, how much wood will he have left over? I want you to take a minute. I want you to try to draw a picture of what that is saying. So what would that look like if he has a square piece of wood with sides 16 inches long and a circle with a radius of 8 inches that he's cutting from the wood? So when we draw the picture, since the circle's radius is 8 inches is half of 16 inches, which is the whole bottom or side of the square, it's always going to touch the edge of the square on the four. If we were to make a T with right angles, it needs to touch on those 4 points. Okay, so the question that's asked is, if he cuts a circle, how much wood will he have left over? So how would we find this out? What would we do? Jake?
You find the area of the square, and then you find the area of the circle, and then you find the area of the circle and you subtract.
Subtract.
Square, good. Or the circle
from the square. Okay, so let's first find the area of the square. It's just side times side, so it would be 16 times 16, which is 256 square inches. Area of the circle, remember, is pi times the radius squared, so we have 3.14 times 8 times 8. When we do that, we get 200.96 square inches. So then if we take away the area of the circle from the area of the square square minus the area of the circle is going to give us what's left. We have 256 minus 200.96 equals 55.04 square inches. So he's going to have about 55 square inches left over. So these aren't really difficult to do in terms of, you're finding the area of two things and subtracting them. The tricky thing sometimes is, if it's a word problem like this one was, trying to figure out how to draw the picture correctly and make sure you're thinking about it correctly. And also, sometimes in the diagrams, deciding what the dimensions are. So we'll look at a couple more examples, and then you'll be working on some. All right, so the first one has two rectangles. This is nice and easy. If we find the area of the large rectangle, let's just say area 1, we just have to do base times height, which is 80 square inches. If we find the area of the smaller rectangle, we do base times height, which is 28 square inches. Subtracting the two, we get 52 square inches. It's a lot easier when they give you the picture. Okay, what about this one? We have two circles, so we need to find the area of the circles. We need to make sure we know what the radius is of each circle. So let's first look at the radius of the small circle. We'll do radius S. What is the radius of the small circle? Violet? 1.5. 1.5. It's telling us that it's 3 centimeters all the way across. Half of that is 1.5. So the radius of the small circle is 1.5 centimeters. What is the radius of the large circle? Adria?
4.
No? Jake?
Would it be 2 because the smaller circle is taking up?
No, we want the radius of if the smaller circle weren't there, what would the radius be? Grace?
Would it be 3.5?
It would be 3.5 because we have, if we were to extend the radius from here, we have to add the 1.5 from the small circle plus the 2 centimeters that are here. So the radius of the large circle would be 3.5 centimeters. Now this becomes a pretty basic problem. We find the area of the large circle by doing pi times the radius squared. And we get, let's see here, large circle 38.465 square centimeters. And then we find the area of the small circle, which is 3.14 times 1.5 squared. And we get 7.065 square centimeters. Subtracting the 2. Gives us 31.4 square centimeters. And I usually don't do much rounding till I get to the last step. Actually, that last step didn't even need to be rounded. The 65s at the end canceled each other out. Okay, any questions before I have you try the next two? All right. Go ahead and try the next two, and then we'll talk about them.
I haven't worn those.
All right, so the first one, the square. Eve, can you tell us what you got?
For this circle, for that area, I got 7.1 yards squared.
What was that?
7.1.
7.1, okay. I usually don't like to round until the end. So you can round your final answer, but I would leave the area of the circle as, should be 7.065. Okay, then what did you get for the area of the square? 9 yards, good. 9 square yards. And then for the shaded region? The shaded region is just what's left after you take away the circle. So if you start with the square, subtract the circle, does anyone have their answer for that? Elena?
After rounding, I got 1.9.
1.9, good. You get 1.935 square yards, and if you round it, that would be correct to round it to 1.9. If you rounded it to the nearest hundredth, you would need 1.94. Okay, let's take a look at the next one. Sky, what is the radius of the small circle?
1.9.
Good. And what's the radius of the large circle?
I didn't get that far, but wouldn't it be, what?
Wouldn't it be what? No, just the radius of the larger circle. No, 3 is only the distance from the outside of this circle to the outside of the large circle. So we need to get all the way to the center. So we need to continue that line. How long is this little piece right here? Seven? Good. This is 1.5. This is just another radius. We could draw radiuses all. We could draw a whole bunch of radiuses. Radii, actually, it's not radiuses. Radius has a plural of radii. Yeah, that appeared one year on a test, and people, not one of my tests, and a lot of people were saying, what does this word mean, radii? And I'm like, I can't tell you. So anyhow, plural of radius is radii. So if you ever see that, that's what that means. So the radius of the large circle, we have to add the 1.5 yards from the small circle to the 3 yards to get 4.5 yards. Kaylin, did you get an answer for the area of the large circle?
63.6.
Okay, I'm going to keep that unrounded, so it would be 0.585 square yards. And let's see, someone else. Dakota, did you get an answer for the area of the small circle? Adria, did you get an answer for area of the small circle?
Yes, the 7.065.
Good. Dakota, back to you. What do I need to do to find the area of the shaded region?
I don't know this. I asked Devin how you do it.
Okay, let's look back at what we did on this one. So we found the area of the outer shape. We found the area of the inner shape. Then what did we do in this step?
Subtracted, well, you did 9 minus 7.65.
Where do we get these numbers from?
The area plus the area of the square.
Good. So what would we do over here to find the area of what's left?
Do 63.585 minus 7.065.
Good. Okay, does anyone have an answer? Michaela?
56.52.
Good. 56.52 square yards.